So today's topic of discussion is relation between stress and strain. Now, when a wire of elastic material is subjected to an increasing tensile stress, the strain changes as shown in this diagram. Okay, this is the initial point from here. Strain. If you increase the stress, strain changes as this. Okay. Now, from this diagram, you can see that up to point A, the relation between stress and strain is linear, right? Which means that the material is obeying Hooke's law. Uh, so, if the deforming force is withdrawn, the wire will return to its original position. So, OA is the region of perfect elasticity. From O to A, you have got perfect elasticity, which means that if the deforming force is withdrawn, the body will revert back to its original configuration. And this point A is known as the elastic limit of the material. This point A is known as the elastic limit of the material. Now, what happens beyond this point A? Now, if the stress on the wire is increased beyond the value corresponding to the elastic limit, now to increase the stress beyond A, then what happens? Hooke's law is unable to predict the elastic behavior of the material. Now, if the stress is removed, the wire doesn't regain its original length. The wire will not regain its original length, and there will be a permanent set or permanent deformation. So the body will behave as a plastic body. The body will behave as a plastic body. Okay. Now, if the process is carried on for some more time, a stage will be reached when the wire is found to undergo a relatively large strain with practically no increase of stress, which means from here, if you see that if we increase the stress very minimal, there will be a huge amount of strain in the wire. Okay. The stress at which this large increase in strain occurs is called the yield point. This is the yield point. Now, see, beyond this yield point, what happens if you increase the strain by a very small quantity? Suppose this. See the change in strain. The change in strain is very much. The change in strain is very much. For a small change in stress, there is a huge change in the strain. So this point B is known as the yield point. This point B is known as the yield point. This point is known as the yield point of any material. Now, what happens? At after the yield point, the solid now flows, means this has become beyond the yield point, the metals become ductile. Gold is a very ductile material because the yield point is very near to very small. The yield point is very small, very less amount of stress is required. Okay. So wires can be drawn out from a solid. If there is a solid rod and you have given a force or a stress such that this body has reached its yield point B, then you can take out wires from this body. You can take out wires from this body. So this is how gold ornaments are made, by taking out wires of gold. Gold is a very ductile material. Okay, so this point B is known as the yield point. Okay. Now, what happens if we further increase the stress? If we further increase the stress, it results in the breaking of the wire. The wire breaks. And this C point is that point where the wire breaks. It is known as the breaking point. It is known as the breaking point. At this point, the wire breaks. Because the force is so strong, it will break the wire. So I hope you have understood this.